Welcome to the Engineering Knowledge YouTube channel. So today I am going to talk about the principles of foundation engineering, right? So in civil engineering, right, foundation is very important part because in any structure we are using the foundation. Mainly the foundation is used to transfer the structural loads to the earth by safely and economically, right? Whether if it is an high-rise building or medium-rise and low-rise buildings, right? We should use the foundation, right, in any structure. So therefore, today I am going to talk about these principles of foundations engineering in especially in the civil engineering, right? So the contents of this session, right? Here there are three areas I have taken. One is the principles of foundation, the next one is the selections of foundation type, and lastly I am going to talk about the construction aspects, right? So why we need the foundation, right? So always, right, as an engineers, as a civil engineers, we should think about that, right? Why we need the foundation, right? So whether it is a building structure or tower structure, right, or bridges, right, foundation is mainly constructed below the ground level, and it is a substructural element, right? Then the foundation, right, is mainly used to transfer the load to the firm soil strata or firm soil layers, or we can say into the bedrock, right? So especially in the high-rise building, we are using the pile foundation. Then in the pile foundation, the rocks, the loads are going to be distributed into the bedrock, right? Then if you consider a structure is made by foundation and superstructures, right? Then in the foundation design, we are considering two aspects. One is the shear, other one is the settlement, right? So we should provide the adequate factor of safety against the shear failure in the foundation design. Other one is we have to consider the allowable settlement, right, in the building construction, right, or structures, right? Then objectives, right? If you think about the objectives of foundation, right? First one is the foundations are going to be used to distribute and transmit the total load, right, to the large area, right, underlying the supports. Second thing is it is going to prevent the excessive settlement, right? The foundations are going to be prevent the excessive settlements and differential settlements of the structures, right? Because in this in the structure, foundation is act as a support, right? Third one is to provide the stability to the structures against many disturbing forces. One is, we can say, wind load, right? Especially in the high-rise buildings and tower structures, we are considering the wind load. And rain, right? So rain normally for in the exposed areas, right? The rain loads, so we can say rain forces, right, also need to be considered. And the last one is the earthquake, right? If there is any earthquake happen in the area, the building should be stable from that vibrations effects. So therefore, we have to consider about the earthquake forces as well, right? And in the construction, right, we are using several material, but in the selections of material and the type of foundation, right, we have to think about the two areas. One is the type of the structure of the building. The second one is the nature of the soil condition or underlying the soils, right? Then before designing the foundation, the proper study, right, should be carried out in the particular area, right? Study about the soil conditions and the physical properties, right? So the detailed study should be done, right, before designing the foundation. The main objectives, if you look at the main objectives of soil investigation or soil exploration, right? One is we are going to find the depth, extents and natures of variations of the soil in the particular area. So we can take this detail from the borehole, right, and the physical properties of soil, right, the moisture contents, particle size, right, those are considered in the physical properties. And the depth of bedrock level, because in the high-rise building we need to know the depth of bedrock, right, and the water tables, right. Other one is the main target is we are going to find we are going to obtain the soil bearing capacity or earth pressure, right, and consider about the seasonal variations, right, of the groundwater table. Normally in the rainy period the water tables are going up, right, and the dry season is going down. So the seasonal variations of the groundwater table also going to be considered in the soil investigation. And the last one is the selections of the suitable foundation type, right. Okay, then in the foundation design there are some governing factors, right. So especially if you are going to consider the clay soil, so you are going to construct the foundation on clay soils. And second thing is, if you are going to construct the foundation on granular soil, right, what are the governing factors, right. So especially in the clay, bearing capacity or settlement may govern the foundation design, right, and in the granular soil, right, we have to control the settlement, right. So foundation designs will be controlled by the settlement, right. Other one is for a satisfactory foundation design, right, the careful calculations in the load, right. So loads transferred to the foundation should be accurately estimated, right. So the structural engineers are going to be calculate the total loads, right, from the design detailing. So even in the design, even in the structural design, we are using Eurocode and BS code, right. And the second thing is conditions of the foundation soil, right. So conditions of the particular area soil, right, should be assessed through an adequate site investigation, right. So maybe in the high-rise building we can use the standard penetration test, right, borehole test, right, and for the medium and low-rise building constructions we are using some trial pits methods, right. So here the trial pits methods and SPT boreholes are used in the soil investigation, right. Then in the design, if you move to the design situation and the limit states of the shallow foundation, right. So the possible shear failure, so possible failures of foundation, one is we can say loss of stability, so that means overturning, right. So overturning failures, right. Other one is the sliding, right, it may be move in a lateral direction. Third one, the bearing failures, sometimes it's going to be settle or moving in vertical direction or downward direction, right. Okay, so those are some kind of situation, right, that in the failure mechanism, these are some possible failures, right, we can found, right, we can be able to found here, right. And we need to know some consideration in finding the foundation width and the thickness, right. So mainly the minimum width of the footing, right, minimum width of the footing is here, here the B, capital B is the width of footing, right, should be greater than or equal, right, greater than or equal 2 times, right, width of your wall, right, width of your wall plus 30 centimeters, right. Even the maximum width of rubble masonry or lean concrete or mass concrete foundations, right, here we can include this condition, right. And for a brick and stone masonries, some conditions for the foundation width, right, for lime concrete, right, and cement concretes, right. Also the thickness, if you consider the thickness, so first one I talk about the minimum width, and the second thing is foundation thickness, so minimum thickness of the foundation, right, at the edge of the reinforced or plain concrete, right, should be, right, equal to 15 centimeters, so 150 millimeters. So that is a minimum, but we are using more than 150 millimeters thickness in the foundation design as normal, right. Then the foundation depth, right? So when we are having the flat level of ground condition, right, and sometimes the foundation depths are going to be different in location to location, right? When you select the locations and the foundation position, right, your direction or the angle, right, is very important, right? So that is right, that is commonly considered in the foundation depth considerations, right? And if you are going to construct a foundation in sloped land or sloping areas, your ratio, right, is commonly we are making in 1:2 ratio for compared to the two foundation, right? If you construct the foundation in slope structure, right, then we need to consider the allowable settlement values or the maximum settlement values. One thing is the foundations may be constructed on granular soils or the clay type of soil. Then for a pad foundation, right, the limiting settlement values are around 40 millimeters. For a raw foundation, we can go with 40 to 65 millimeters as the limiting values. And for a clay soil, right, pad footings or pad foundations, we can use up to 65, and raw foundation 65 to 100 millimeters. So that is the limit or allowable settlement values, so maximum settlement values, right? Then the foundation, right, so mainly we can divide the foundation into two types. One is shallow foundation, other one is a deep foundation, right? So the shallow foundation means the ratio between depth of footing is to breadth of footing, or the width of footing is less than 1, right? That is we call as a shallow foundation. So this definition is actually, this principle is stated by Tesaki, right? And second thing is deep foundation or pile foundation, right? So mainly the piles are going to be used to transfer the load in firm soil or in the hard soil layers. Otherwise you have to go with the bedrock level, right? Then in the foundation, I told that shallow and the deep are the two foundation. Based on the method of construction, right, shallow foundations can be again categorized into 5 types. One is strip, pad, combine, raft, and the strap foundation, right? So shallow foundation in terms we can say spread footing, right? Because the shallow foundations contains mainly spread type of footings. So therefore here pad foundations, combined foundation, strip footings and strap foundations are commonly used. Also the raw foundation also taken as a spread footing or shallow foundation. Other one is deep foundation, right? Especially in the deep foundation, right, we are using the pile walls and the diagram walls, right? In the shallow foundation construction, right, commonly the foundation depth is less than 3 meter, right? Some advantages, right? The very cost is very less and the construction procedures are very simple, right, in the shallow foundation compared to the deep foundation, right? Shallow foundation construction procedures are very simple, and commonly we use concrete as the most material, right, and we don't need much labors, right? Then if you look at the foundation for a single story buildings, or we can say low rise building, right, we can use a rubble foundation, right, and rubble foundations with plinth beam. So actually the plinth beams are introduced, right, when the soil condition is going to be weak. Then we have used the plinth and distribute the load on the soil, right? And rubble foundations with concrete beds, right? In case if the soil is weak, one option we can increase the concrete bed and follow the same rubble foundation on the concrete bed. And the last one is inverted T types of foundation, right? also practiced in the single story buildings, single story houses, right? And these are some the shallow foundation types, right? Especially in the pad foundation, square shape of pad foundation, rectangular shapes and circular shape of pad foundations are used in common practices, right? And in the pad foundation, commonly there's only one column, right, with a single footing, right? So that is identified as a pad or isolated footing. In the combined foundation, minimum 2 columns will be started from the single base or single footing, right? Especially where the columns are very close, we can go with the combined footing compared to the individual pad foundation, right? Some reinforcement detailing, right, here in this figure, right? The reinforcement detailing for the base and the elevation views are illustrated, right? And in the strip footing, commonly in the boundary wall constructions and load bearing walls, we are using the strip footing, right? Strap foundation is actually the two individual pad foundations are going to be combined or tie with the tie beam, right? So we introduce a tie beam to minimize the differential settlement in the building, right? So we can connect the two pad foundation by the tie beam and minimize the differential settlements, right? And the last one is raw foundation. So raw foundations are commonly used in the multi-story buildings and medium rise building because all the structural columns are going to be start from the common base or common footing, right? And all the columns will tie with the tie beam. So the large area, the foundation area is actually high, then we can reduce the pressure on the soil, right? So that's why the raw foundations are very economic and mostly used in the multi-story buildings and medium rise building, right? And if you move to the deep foundation, right? So deep foundation, right, where the shallow foundations are not adequate to transfer the load, then we have to go with the deep foundation type, right? Then in the deep foundation, I told that the high-rise buildings commonly use the pile foundation or deep foundation, right? Because any type of shallow foundation couldn't bear the load of this, couldn't bear the load, and there is no any soil, right, could not support to the building pressure. Therefore, we are going with the pile and transfer the load in firm soil or bedrock area, right? So the deep foundation concept, commonly the depth is more than 3 meter, right? According to the load transfer mechanism, pile foundation also categorized into 5. One is the end bearing piles, right? Mostly in the end bearing pile, loads are distributed in the tip end, right, at the bottom. And the second one is the friction or floating piles. So here in this friction type of pile, load will distribute over the perimeter areas, right, over the circumference areas, right? And replacement piles or non-displacement piles, actually in the non-displacement piles are used in the construction industry because we are setting out the pile location and we drill the holes of this pile, and all the pile construction works are going to be held at the site. Fourth one is the displacement pile. In this case, we can use the precast pile, right? Maybe steel, timber, concrete, right? Precast piles are commonly used, and with the help of hammers, we can lower the pile into the ground, right? And the last one is the cast in situ piles, right? So here the load transfer mechanism in the end bearing pile, and for the friction pile, you can see the picture, right? What's happened in the end bearing and friction piles, right? And in the non-displacement piles, right, we set out the pile locations, but in the displacement pile, I told that commonly we use the precast pile, so maybe it is steel or concrete, right? Then in the precast pile we have to use some machineries and hydraulic hammers to lower the pile into the ground. So hydraulic jacks and hydraulic hammers are going to be used in the pile driving, right, especially in the displacement pile. But I told that this non-displacement pile is a common form of pile we are using, because we do all the works at the site. So you are drilling the holes and you are going to lower the reinforcement and do the concrete. All the works are executed at the site, right? And here, you know, the last one is the cast institute piles. So here also there should be a detachable shoe. We place it at the bottom, right? And we do all the works at the site, same similar to that, right? And that is the last one commonly used, right? So thank you. I think you maybe got the basic idea about the foundation from this session. Thank you all. Please support our engineering knowledge YouTube channel. If anyone watched this video, please share and like and share with you.